In this lecture, I will discuss the system development lifecycle. In previous weeks, we have discussed using the system development lifecycle methodology when creating a new system. This methodology is used to create a system that meets the need of the end user. It offers a more structured approach to developing a system. There are 5 phases of the SDLC: system planning, system analysis, system design, system implementation, system support, and security. The planning phase is the most important phase of the SDLC. It describes the problem or opportunity that would be solved by implementing the new system. This is the phase that will investigate to see if it is feasible to continue to pursue the new system. If this is not done correctly, it will cause the entire project to be incorrect. In this phase, you would do a requirement analysis. It is the most important and fundamental stage of the SDLC. It is performed by a senior member of the team, and it is often gathers information from the customer as well as other professionals in the area. In the analysis phase, you would examine the existing system. You will need to determine the exact problem that needs to be resolved by the new system. In this phase, you will determine and document the requirements that the new system will need to meet. After this phase is complete, you will have clearly defined the system requirements. It is important that you have clearly defined system requirement, as this is the guideline that you would use in selecting and implementing your solution. In the design phase, you are not actually developing the system. You will be creating all of the specifications to create the system. You will be creating data flow diagrams, entity relationship diagrams, and process flows. The documents developed in this phase of the SDLC will serve as the blueprint for creating the system. Having a well-documented system helps to ensure that you design a quality system. It allows you to really view the system, ensure that the system will work before you actually create the system. In the implementation phase, you will use specifications created during the design phase to create the system. In this phase, you will need to consider how you will convert from the old system to the new system. There are several conversion methods as discussed in previous lectures: the direct cutover, the phase, the pilot, and the parallel. The direct cutover is when you stop using the old system and start using the new system. The phase is when you implement the system in phases by only introducing portions of the system. For example, if you had a large system, you could just implement the accounts payable module and then the accounts receivable module. The pilot would focus on small groups of implementation and continue until all locations have been converted to the new system. The parallel method is when you use both systems until you feel comfortable with the new system. The method that is used for conversion will depend on the size and the risk of the new system not functioning correctly. In the support and security phases, you will continue to review the system to work out potential bugs and ensure that the system is properly secured. You will ensure that the system is reliable, maintainable, and scalable. There are advantages and disadvantages of using the SDLC. Some advantages are: you have formal reviews at the end of each phase, creates system documentation, you have involvement from both your users and your managers. Some disadvantages: that lack of needed skills. Users don't see the system until it's completed. The process can be time consuming and documentation can be expensive. There are 4 models that can be used when using the SDLC: the waterfall model, iterative, spiral, and then the V model. With waterfall model, it's the first process model introduced and is also known as the linear sequential life cycle model. Each phase must be complete before the next phase can begin. Some advantages of using the waterfall model is that it's simple and easy to understand. Each phase is processed and complete at one time. Stages are clearly defined, and it's easy to arrange project tasks. Some disadvantages is that it does not use reflection or revisions. It's difficult to go back and make or change when not well documented. It's not a good model for long and ongoing projects, and there is a high amount of risk that's associated with using this model. The next model is the iterative model. It starts small and with a small set of software requirements. Iteratively enhances with each version until the complete system has been implemented. Some advantage of using this model is that it has working model on the system in the early stages. You can easily find design flaws and take corrective action. It is less costly to change the requirements, and you have an operational product is developed for each increment. Some disadvantages is that it's difficult to break an SDLC project into small parts because it's designed to be used on large software development projects. To use increments, you have to define the complete system, and it's not suitable for small projects. Managing projects can be more complex when using this model. The next model is the spiral model. The spiral model is a combination of iterative and waterfall model. It has a high emphasis on risk analysis. It continuously passes through iterations until the software is released. Some advantages of using the spiral is that it accommodates changes in the requirements. It allows extensive use of prototypes. It accurately captures requirements. The users get an early view of the system, and the system is developed in small parts. Some disadvantages is that it can be difficult to manage the process. It can't project when the project will end, and it only works with small or low-risk projects. And it requires more documentation than other models. With the V model, it is also known as the verification and validation model. It executes processes in a sequential manner in a V shape. It is an extension of the waterfall model and is based on and associated on the testing phase. The development phase is planned in parallel with the testing phase. Some advantages of using the V model is that it's a highly disciplined model. Each phase is completed one at a time. It's easy to understand and use, and it's easy to manage. Some disadvantages of using the V model is that there is a high risk and uncertainty. It's not suited for complex projects. It also is not suited for projects that have a high risk of changing. And it does not produce working software until late in the life cycle.